Hi class, for this sections, we're going to talk about the derivative as a function. So in the previous sections, we considered the derivative of a function at a fixed number a, right here. So this time, if we replace a with x, we get the function. So now we have the derivative of f as a function, and that's the equation right here for the derivative. Now let's take a look at example 1. So the graph of function f is given. As you can see, this is a polynomial. We want to use this graph to sketch the graph of the derivative function. So let's just plot some point. So you can see right here, I can have this, I will tell you why I want to take care of these points. And let's just pick a random point. Let's just say this point right here and cause P. Okay, so as x equals 5, we draw the tangent line at P. So it's right here, right? That's a tangent line. Right here. Now the tangent line, and we estimate the slope is about 3/2. So if you plug it in, f prime of 5 is about 3/2. So we use it to plot the point P prime. So I'm going to use it and I plot the point. P prime, which is 5 and 1.5. Okay. So if we try to repeat this procedure at several points, we're going to get the graph. Now, so it's going to be a curve like this. Okay, now I want to point out these points. You see at these points, the tangent lines are horizontal. Okay, so if the tangent lines are horizontal, that means the slope is 0. So we know that at these points, the slope is going to be 0. So this is going to be A prime. This one I'm going to call, this is A, this is B, and this is C. So this one right here is B prime. And this one right here is C prime. Okay, so now we have to notice something. So we know that the derivative is 0, and the graph of f prime crosses the x-axis at the point A prime, B prime, and C prime, directly beneath A, B, and C. But between A and B, the tangent have positive slope. You see right here, the tangent has positive slope. From B and C, the tangent is negative. Okay, so keep that in mind. All right. So we want to sketch. So we have to cross A, and then it's positive. We have to cross B. Now from B to C is negative, and we cross C. And there. So now we get the graph of f prime. Moving on to example 2. So you see example 2, they are looking for the formula for f prime. So we're going to use the limit. So by definition, I'm just going to rewrite the formula. So f prime of x is the limit as h approaches 0, f of x plus h minus f of x over h. Okay, and then from here, you plug it in. Limit h goes to 0. We have x cubed. So I'm going to do x plus h, and we have to cube it, minus x plus h, and then we have x cubed. This is f of x cubed minus x, over h. Okay, so make sure you FOIL, do all of that algebra work. We're going to end it up with, hopefully I'm not making any mistake here. So h approaches to 0. We're going to end up with x cubed plus 3x squared. H plus 3x h squared plus h cubed minus x minus h minus x cubed and plus x. Okay, everything over h. All right, so let's cancel things out. So we ended up with the limit h approaches 0, 3x squared h plus 3xh squared plus h cubed minus h. Everything over h. All right, so if I factor out the h, I can simplify with the bottom. So I'm just going to cross it out here. So pretend like I actually factor it out. So because this one has 2h, so I'm going to cross out that one. And this one, let's change this to 2. This one, we get 1. All right. So now after we simplify, we ended up with limit h approaches 0, 3x squared plus 3xh plus h squared minus 1. But if you plug in 0 here, 0 here, and 0 here, let's cancel out. So we ended up with 3x squared minus 1. Okay, perfect. So that's the f prime function, which is the derivative. Now, let's take a look at example 3. Example 3, we have square root of x. So same thing, we're going to use the definition. Using a definition, limit h approaches 0, f of x plus h. The reason I keep rewriting these formula is so the more you do it, you're gonna eventually remember it. So limit h goes to 0. The square root of x plus h minus square root of x over h. Okay, so every time you have the square root function, obviously you cannot cancel out with the bottom, right? So we need to somehow get rid of the square root. And a way to get rid of the square root, hopefully you still remember, is to multiply top and bottom by the conjugate. So in this case, the conjugate is x plus h plus square root of x. So that's the conjugate. Hopefully you remember. So the conjugate are exactly the same except for the sign. You see that? So originally we have negative. So when the conjugate is a positive, it's the opposite of it. Okay, so after that, we just simplify it. And like I said, the whole point of multiplying by the conjugate is so we can cancel out the square root. Because don't forget a plus b times a minus b is a squared minus b squared. So we end up with this. And in the bottom, we still have x plus h plus square root of x. And then don't forget, we still have that h. All right, so we cancel out x. You see h, top and bottom right here. We cancel out. So we ended up with one over square root of x plus square root of x, which is 1 over 2 square root of x. And that's going to be our function. So that's the f prime. Now, they ask you to find the domain. So this is a square root function. So the domain has to be positive number. So f prime. Exists if x is positive. Therefore, the domain is from 0 to infinity, positive number. Now, you see, because we do not want to include 0, that's why I have to keep the parenthesis here. Okay, because don't forget, we are not allowed to have 0 on the bottom here. Okay, if I ask you for the domain of the original function, then you can include a 0. But for the derivative, no, you can't do that because it's on the bottom. All right, so moving on to example 4. Okay, so same thing. They want you to find the f prime. They want you to find f prime. So f prime in this case, because we're working with a fraction, so there's all of these problems. The tough part is the algebra part, not the calculus part. So let's write the limit. Hopefully by now you know the definition. So I'm just gonna I'm just going to plug it in. So f of x plus h in this case is what? 1 minus x plus h over 2 plus x plus h minus f of x. So it's minus 1 over x, 2 plus x, everything over h. Okay, so as you can see, you have to find the LCD. Okay, so finding the LCD, I have to multiply the LCD to simplify them. So here, hopefully I have room. There we go. Don't forget the original h. So let me just highlight the original h for you. Okay, so pretty much we multiply by the reciprocal. So when we divide, you multiply by the reciprocal. All right, let's simplify it. Two minus x minus 2h minus x squared minus xh minus 2 minus x plus h minus x squared minus xh. Everything over h. 2 plus x plus h. 2 plus x. All right, let's do some cancellation. So what do we have? We have 2 minus 2. We have x, and then this is positive. We have this one and this one, this one and this one. So we ended up with negative 2h minus h, which is 3h, negative 3h. Over h, 2 plus x plus h, 2 plus x. And then don't forget, I can just simplify h on top, h on the bottom. So we ended up, and then you plug 0 in for h. We ended up with negative 3 over 2 plus x times 2 plus x. So that's 2 plus x squared. And that's our derivative function. All right, so all the notations we use is the y prime here. Okay, so these are all different notation. Okay, so the simple d and d over dx is called differentiation operators. Okay, differentiation. And then you will see that we use dx over dy a lot. So make sure you know that notation. Now, this is very important. It's a definition of differentiable. So a function is differentiable at a if we have the derivative at a. Okay, so let's take a look at example 5, and this is the absolute values function. So we want to know if f of x is differentiable or not. Okay, so we're gonna have to see if in fact they have in fact this function has the derivative. So what can I do? I'm just checking to see if I have enough room. All right, so let me just sketch the function. So that's absolute values function. Okay, so we have to consider x when x is positive and when x is negative. So first, if x is positive, then the absolute values function is just x. So we can choose h small enough. So I'm going to choose an h small enough. So when I add, I still get a positive number. Okay. So because of this, the absolute values of x plus h is going to be positive x plus h. So for x greater than 0, we have f prime of x equals to the limit of x plus h minus, I'm just using a definition here, over h as h approaches 0. And that's by definition is just x plus h minus x over h. So what do we have here? Okay, so we have 1, right? So f is differentiable. F is differentiable for x greater than 0. Now let's try negative. So x less than 0. What do we have? We have this the absolute values of x is going to be negative x. So once again, we're going to choose h small enough so when we add h to x, we still get a negative number. So what do we know? X plus h, and we take the absolute values, we're going to end up with a negative x plus h. So for x negative, what do we have? Once again, I'm going to take the limit. H goes to 0, x plus h minus absolute values of x over h, which turn into negative here, negative x plus h minus negative x over h. So we ended up with, so you can see right here, so I ended up with a negative 1 because it's negative h over h, which is negative 1. Okay, so we do have an f prime. So f is differentiable. For x negative. Now, because I check positive, I check negative, I have to check when x equal to 0. So that's important as well. So let's check when x equals 0. X equals 0. So once again, I'm going to take the derivative. So what do we have here? When f prime equal to 0. So it's going to be f 0 plus h minus f of 0 over h, which is the limit h approaches 0, absolute values of 0 plus h minus absolute values of 0, h, which is what? The absolute values of h over h. Okay, now that's going to be the limit, but because we don't know what's going on here, so how do we find a limit? How do we know for sure we have the limit? We have to compute left and right to see if they are in fact the same number. So we have to go and take the limit as 0 approaches from the right. So what happened when we look at only the right? The limit as h approaches to 0 from the right is going to be the positive h over h, which is 1. Now if you look from the left of 0, h approaches 0 from the left, it's going to be what? It's going to be the absolute values of h over h, and it's the limit h goes to 0 from the left. It's going to be negative h over h, turn out to be negative 1. All right, we do have a problem. So 1, we have 1 for the right and negative 1 for the left. So they're different. Therefore, we can conclude that f prime of 0 does not exist. Okay, so f is not differentiable at 0. At 0. Okay. There we have it.